Okay, so we are solving problem 34, chapter 2 of Halliday, 9th edition. So in this problem, we have two cars. One is a red car and the other one is green. I'm going to call it a blue car, okay? So we have the red car moving to the right, and we have the blue car moving to the left, okay? If you read the whole problem, what we know is that this red car, the red car is moving at constant speed. Okay, so the velocity of this red car does not change. And if you go through the whole problem, you will understand that the blue car is accelerating, well, has an acceleration. Okay, so it has a certain initial velocity here, which we do not know. We are going to try to find, and it has a certain acceleration, which we also do not know. We are going to try to find. Okay, and well, what are the position of these cars? We choose a frame so that this initial position of this red car is 0, and the initial position for this blue car is some distance away, from distance away from the red car, which is 220 meters. Okay, so again, if you read the problem, there are two unknowns, which are the initial velocity of the blue car. This is an unknown we want to find, and the acceleration of this blue car. So these are the two things that this question is asking us. Since we have two unknowns, we are going to need two equations to solve that. So let's see what the problem gives us. It says that if this red car, so if the red car is moving with this constant velocity that it has, and if the magnitude of this velocity is 20 kilometers per hour, 20 kilometers per hour is approximately 5.56, 5.6 meters per second, okay? So when the red car is moving at this constant speed, it then meets the blue car at this position, 44.5 meters, okay? Both cars meet. Let's already start setting equations based on this information. We know that the red car is moving at a constant velocity, so I'm going to write here the equation for this red car. The initial position plus the velocity t. Well, the initial position is 0, so I don't need to write. If the velocity is 5.56 meters per second, this is the equation that we have. Okay, how about our blue car? What is the equation for the blue car? Well, we know there is acceleration for the blue car, so I'm going to try to write this equation. The position for the blue car is its initial position. That's the equation. I'm just writing the equation. It has an initial velocity, which we do not know, t, acceleration over 2t squared. This is the equation, but now let's put the numbers there. Well, so that means that the position of the blue car is its initial position, which is 220. Remember, from our drawing here, this is 220, so I put it there. The initial velocity, I don't know, so I'm going to put it here because this is my unknown. Okay, so I'm going to even circle it to remind us that this I don't know. Then we have time. The acceleration, well, that one also I do not know, so I'm going to circle it to remind me, okay? And then divided by 2 and t squared. Okay, so this is the equation for the blue car. And this other one, the equation for the red car. When this red car has this velocity, these two cars meet at this position that we wrote here, 44.5. Okay, so that means that they will meet. No? So the position of the red car will be equal to the position of the blue car, which will be equal to 44.5 meters. How can this information help me? Well, I can find with this number, I can find the time when they meet using this equation here. So let's do that. I'm going to find the time using that, the position for the red car here is going to be 44.5 meters equals to 5.56 t. And then from here, you're going to find what this time is. So this time, which I found, is more or less 8 seconds. So double check that my calculations are correct, but it's more or less 8 seconds. All right. Now what I'm going to do with these 8 seconds, I'm going to put it here in this equation, okay? I also know the position of this blue car at this time will be 44.5. That's when these two cars meet, 44.5 equals to 220 plus that initial velocity, which we do not know. The time, I'll put this time 8 seconds here. The acceleration, well, that I also do not know. The time is 8 squared is 64. Okay, so look at this. We now found one equation which contains the two things that we want to find, the velocity and the acceleration for this blue car. But it's just one equation and we have two unknowns, so that's not enough. But let's keep this equation there because it's useful. Let's now see what is the other information that the problem gives us. They say that is very similar to what is written here, but if this red car, instead of 20 kilometers per hour, if it moves at 40 kilometers per hour. Okay, so if this, remember the red car is always moving with constant velocity. Okay, so the other piece of information is if the velocity of the red car, which is constant, is 40 kilometers per hour, and you can check that 40 kilometers per hour is approximately 11.1 meters per second. So if it moves at this constant velocity, what is going to happen is both cars will meet again, but both cars meet now at a different position, meet at this position 76.6 meters. Okay. All right, so this is the other piece of information. And what are we going to do with that? The same procedure that we did here. Use the equation for the red car to get the time. So let's do that. Use the position for the red car to get the time. What is going to be this final position where the two cars meet? 76.6. The initial position is 0 and the velocity now is 11.1 multiplied by this time. What we get here, the time is now 6.9 seconds. Makes sense that the time is shorter, right? Because now this car has a bigger speed. Okay, so let's keep this here. That's what we got for the red car. How about the blue car? Well, the equation for the blue car is the initial position, velocity, acceleration. Let's see what we can put here. Well, the position, what is it going to be? 76.6, that's when the two cars meet. What is the initial position? 220. What is the velocity? We do not know. That's what we are trying to find. What is the time? 6.9. What is the acceleration? I don't know. We are trying to find. Divided by 2. What is the time? 6.9 squared. Okay, so let's mark here again the two things that we do not know. We do not know this, we do not know that. So look now, I have this equation and we have this other equation. So we have two equations and we have two unknowns. Now we will be able to find them. Okay, so now it's a little tedious. Now it's just a matter of being patient. So let me rewrite these two equations here. And now it's really just math. So one equation is this: 44.5 equals to 220 plus 8 V naught of this blue car, the initial velocity, plus 32A is the top equation. You can check. Okay. The other equation is this one that we just found. So let me rewrite it as 76.6 equals to 220 plus 6.9 V naught of this blue car. This is the acceleration of the blue car. And then here plus 47.61 divided by 2, and this acceleration of the blue car. Okay. These are the two equations. You just now have to be careful and solve this system of equations. Two equations, two unknowns you'll be able to solve. So what can you do? For example, you can isolate A from here and then plug it there to find V naught. Once you find V naught, you can come back to this equation or any of these two equations to get A. Okay, so this is the idea of this problem. It's a little tedious, but it's not that hard.